Hello students, good evening all of you. First of all, I would like to all the best for your NEET June 21st examination. Today in this evening session, we are going to deal with current electricity, most important chapter in physics and high weightage chapter in physics. Current electricity, usually 2 to 4 questions you can expect in NEET examination. If you go through the previous NEET examination papers, most of the cases, 3 or 4 questions they are giving in from current electricity. In fact, on May 3rd, recent NEET exam, they have given 4 questions from current electricity. Means 16 questions, 16 marks. 4 questions they have given, 16 marks. And this current electricity is so important because of 2 reasons. One is because of this high weightage, and second is this chapter is linked with some other chapters like moving charge and magnetic field, electromagnetic induction, AC circuits, and semiconductors. This chapter is linked with them also. Hence, in this current electricity, strong foundation is essential, dear students. And now, I'm going to give you some important tips, tricks to solve the problems, elimination methods, time-saving techniques of solving the numerical problems today evening now. Now, we are going to solve, together we are going to solve some important NEET level problems from current electricity, starting from basic to tricky rank improving questions we are going to solve. To be ready with your notebook and you try to solve every problem before I solve it. And by the end of this chapter, you should feel confident to attack any problem on current electricity in the examination. So let us play with current electricity and enjoy without getting shocked. So let us start now. In this chapter, you need to focus on Ohm's law, drift velocity, Ohm's law, drift velocity, series and parallel combinations of resistors. These are areas you should focus more. Series and parallel combination of resistors, Kirchhoff's laws, Wheatstone bridge, meter bridge, and electrical power. These areas you have to focus. And if your concepts are clear on these areas, then you can solve any problem on current electricity quickly. So now let us start solving the problems. through problems, let us discuss the concepts and the tricks and tips. The first problem, if you look at this circuit, has given a junction of three resistors and is asking in the following network, find the potential at the junction O. And when you look at these, three resistors junction is showing. That indicates that this problem is based on Kirchhoff's first law. What is that first law? Law of junctions, law of currents. It is based on Kirchhoff's first law. Law of junctions, law of currents. The total current flowing into the junction is equal to the total current flowing out of the junction. This law is nothing but law of conservation of charge. And you know the second law, Kirchhoff's second law, law of voltages or law of loops, that is law of conservation of energy. First law is law of conservation of charge. So in this problem, when you look at that junction, immediately you'll get idea that we need to apply Kirchhoff's junction law. Kirchhoff's law along with Ohm's law, we should apply to get solution for this. So let us assume the potential at this junction is V naught. And let us assume the current flowing from A to O is some I. And this current here splits into these two branches. And let us assume the current from O to B as I1 and the current from O to C as I2. Then according to Kirchhoff's law, I is equal to I1 plus I2 I can write. This is Kirchhoff's junction law. Now comes Ohm's law. Current flowing between A and O must be equal to the potential difference between A and O divided by resistance between A and O. That is Ohm's law. Potential difference between A and O. Write it. Potential at A is 8 minus potential at O is V naught, we assumed. 8 minus V naught by resistance between these 2 points is 2. Similarly, write I1. It is the current flowing between O and B. Potential difference between O and B. Potential at O is V naught. Potential at B given as 4 volts there. V naught minus 4 by resistance 4. Then write I2. Potential difference between O and C. V naught minus 2 by resistance between O and C is 2. Substitute this here. 8 minus V naught by 2 is equal to V naught minus 4 by 4 plus V naught minus 2 by 2. Okay, you can cancel 2 now. Here 2 will cancel here. I am writing 8 minus V naught equal to V naught minus 4 by 2. 2 times cancel here. Plus V naught minus 2. Then 8 minus V naught. Don't take LCM here. It will become lengthy. 8 minus V naught equal to, this is split into two fractions, V naught by 2 minus 4 by 2, 4 by 2, that is 2, plus V naught minus 2. Then V naught, 8 minus V naught is V naught by 2 plus V naught, 3 V naught by 2 minus 2 adding, minus 4 you'll get. Then bring 4 here, V naught there. You will get 8 plus 4, 12 equal to 3V naught by 2. This minus V naught bring here, plus V naught it is. Then you'll get 12 equal to, now take LCM, 5V naught by 2. That implies V naught is 24 by 5. 4.8. Fourth option you are getting. Now in this question, instead of asking the potential at the junction O, they may ask any current in any one branch here. They may ask find the current in this 2 ohm resistance or find current in that 4 ohm resistance, anything. Using this you can find. Now substitute V naught value in any one of these equations, that corresponding current you will get. Suppose if they ask find the current in 4 ohm resistor in this network, now this I1 in this V naught value, you substitute and find the current. V naught 4.8 minus 8 by 4. 0.8 by 4. 0.2 ampere you will get. 4.8 minus 4 by 4. 0.2 ampere current flowing in this. Like that, you can find even current in any one branch in this. Okay? Now let us see the next problem. See again Kirchhoff's law. Second law. Loops are there na here. Previous problem, junction is there. Kirchhoff's first law, junction law we applied. Now if you look at this network, loops are there. Kirchhoff's loop law, law of voltages, we need to apply now. What is asking in this network? The cells have zero internal resistance given there. The currents passing through resistances R1 and R2 are is asking. Current in this R1 and in this R2 is asking. Then how to solve this? You take current, some current from this battery. Current direction is always shown from positive terminal of battery, no? So here you take some current I1 coming from this first cell. If current coming from positive terminal of cell, if you take it as I1, the current going into the negative terminal of the cell must be I1 only, no? Same I1 should go into its negative terminal. Similarly, from this cell positive terminal, current coming out, I'm taking as I2. Then the current going into this negative terminal of the second cell must be I2. Now this I1 and I2 currents combine and the current flowing in this middle branch will be I1 plus I2. This I1 plus I2 at this junction again will split into two branches. This side I1 should only come. I1. This side I2 should be there. So first like this, you find out how the currents are flowing in this network first. Then apply Kirchhoff's loop law. Let us take first this loop. Let us name this A, B, C, D, E, F. Now for this closed loop A, B, C, D, F, I am applying Kirchhoff's law. A, B, C, D, A. A, B, C, D, A. For this closed loop, Kirchhoff's second law, I'm applying. So let us start, remember the sign convention used here? For any resistor, when you are writing the potential difference across any resistor, what is that? Product of current and resistance, potential difference. For this, the sign convention, if you are going along the same direction of current in that conductor, then this potential difference is taken with negative sign. If you are going opposite to current, then this potential difference I into R taken as positive sign. Whereas EMF of cell, for that when you write, if you are going from positive to negative terminal of the cell, its EMF must be written with negative sign. Positive to negative terminal side, if you are going, take its EMF with negative sign. If you come from negative to positive terminal side of cell, the sign convention is take its EMF with positive sign. So I'm applying this. Start from A, go to B, then to C, then to D, and come back to A. Travel along this and write the algebraic sum of EMFs and potential differences and equate that with 0. So let us start from A. Start from A, move up to B, between A and B. What is there? What is there here between A and B? Resistor is there. That means there is potential drop between A and B. Potential difference is there. That potential difference is I into R. And we are going in the same direction of this current. No? A to B we are going. Means in the same direction of current we are going. So with negative sign you have to write it. So minus I1 plus I2 into 20. Now travel from B to C. Between B and C, there is no resistor here. And there is no cell also. That means there is no potential difference between B and C. B and C are at same potential. Similarly, C and D also. They are at same potential, C and D also. Then move from D to A. Between D and A, there is a cell. And that cell doesn't have any internal resistance. He gave it 0 internal resistance. If it has internal resistance, some small r, you have to write potential difference. I1 into R, you have to write I1 into R. In the same direction of current, if we are going now, minus I1 R, we have to write. But there is no internal resistance for this. Only EMF. And while going from D to A, you are going from negative to positive terminal side of that cell. So its EMF must be taken with positive sign plus 10. This is the algebraic sum of EMFs and potential differences in this loop. This value must be equal to 0. According to Kirchhoff's second law, which is nothing but law of conservation of energy, this now minus 20I1 minus 20I2 minus 20I1 minus 20I2 plus 10. Plus 10 I am taking that side is minus 10 you are getting. Then what you will get? Minus, 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 cancel. No? 0, 0, 0, cancel. No? You will get 2I1 plus 2I2 equal to 1. One equation you got. Now Kirchhoff's law, second law, loop law, you apply for second loop A, B, E, F, A. A, B, E, F, A. For this loop you apply. Similarly, start from A, go to B, then to E, then to EF and come back to A. A to B minus I1 plus I2 into 20. Then B to E, there is no cell, there is no resistor, B and E are at same potential. And E to F, there is a resistor, 20 ohm is there. So its potential difference you have to write in the same direction of current we are coming. So minus 20I2 minus 20I2. Then move from F to A. F to A. F to A, when you are coming from negative to positive terminal side. Positive EMF you have to write. Plus 10 is 0. Minus 20I1 minus 20I2, again minus 20I2, means you will get minus 40I2 is, take that side, minus 10, minus, 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 cancel, 10 also cancel. So you'll get 2I1 plus 4I2 is 1. This is second equation. Now solve these two equations and find I1 and I2. Solve these two equations. One equation, second equation, first I'll write 2I1 plus 4I2 is 1. First equation, 2I1 plus 2I2 is 1. If I subtract these two, 2I1 cancel, 4I2 minus 2I2 is 2I2 is 0. I2 0 you got. I2 0. Now this in first equation I2 0 you substitute. In first equation I2 0. Then according to first equation, from first equation what you are getting? 2I1 is equal to I2 0 now. This is 0. 2I1 equal to 1 you are getting. That means I1 is 1 by 2, 0.5 ampere. I1, I2 0. Now the question is, what are the currents passing through resistances R1 and R2? In R1, I1 plus I2 is current. I1 0.5, I2 0. 0.5 plus 0. 0.5. Current in R2 is I2. That is 0. So 0.5, 0. Third option. So Kirchhoff's first law, first problem, Kirchhoff's first law application. And the second problem is Kirchhoff's second law application. Kirchhoff's laws very important. You need to practice. You need to practice more this chapter. In fact, physics means you need more practice. If you have more practice in physics, then you can quickly understand what is problem and you can quickly solve and save time. Practice very important for physics. Practice makes all perfect. Okay, I'm going to next problem, third problem. Third problem, a wire of resistance R is bent into a circle of radius small r. What is the equivalent resistance between those points X and Y? That is asked. So there is a straight wire of total resistance R. This straight wire of total resistance R is made into the form of a circular loop. Means this complete circular loop resistance is R. Now what you are doing, you are finding the effective resistance between these points X and Y. Means what is the meaning of this? Between X and Y, if you connect a battery, then what is the effective resistance of this network? Is asking that. See, if you connect a battery like this between X and Y, the current coming from battery at this point I splits into two branches like this. I2, I1 like this, I2 will flow like this, I1 like this, and then flow into this. I1 will come to this point Y. I2 will flow like this and come to this point Y. Again at the point Y, I1, I2 combine to form I. Again I. And this segment XW, this W, XWY, this segment XZY, this segment. Both are under same potential difference. They are in parallel combination. So if this resistance of XWY, if it is R1, XZY resistance, if it is R2, these two are in parallel combination. No? So what is the effective resistance between these points X and Y? R1, R2 parallel. So R1, R2 by R1 plus R2. Now effective resistance when the two are in parallel. But R1 plus R2 means this total loop resistance R only. So it is R1, R2 by R. What is R1? What is R2? See this? Resistance is rho L by A, where L is length of the resistor and A is the area of cross section, rho is resistivity. These two segments are made of same material. No? So rho same, no? Area of cross section also same, no? Both are same area of cross section. Not circle area, that wide area of cross section. Same, no? For both. That means resistance proportional to length of these segments. But what is the length of arc in a circle? You know that? Length of the arc in a circle formula you know now. R theta. Means length of the arc is proportional to angle. So resistance proportional to L, L proportional to theta. Like these tricks you have to use, should not make lengthy calculations. R proportional to L proportional to theta. So R1 is to R2 must be equal to theta 1 is to theta 2. Means R1 is to R2 is theta 1 some alpha given there alpha. This angle. Mean this backside remaining angle how much? 360 minus alpha. 2 pi radians minus alpha. So theta 1 is alpha, theta 2 is 2 pi minus alpha. That means this total resistance R is made into two parts, R1, R2 according to this ratio. So R1 is how much? Suppose if the ratio R1 is to R2 is 2 is to 3, suppose if you have like this, what is R1? Two parts in R1, 2 out of 5 parts, 2 by 5 of total resistance. 2 by 2 plus 3, 5 into total resistance. Like that, R2, 3 parts in R2 getting 3 by 2 plus 3, 5 into total resistance. Like that, you do this. R1 is alpha by alpha plus 2 pi minus alpha. Alpha, total angle 2 pi. Alpha by 2 pi into total resistance. What is R2? R2. It is 2 pi minus alpha by sum of these two means total angle 2 pi into R. So this now I have to substitute here. If I substitute here R1 into R2 when I do this, in the denominator 2 pi into 2 pi 4 pi square I am getting. See here. Only in one option 4 pi square is there, in no other option. Only in one option is there, first option. So this is the answer. Elimination method you apply. First option is right. Substitute R1, R2, these two here and simplify. You'll get first option only. That is this problem. Finish. Now I want to discuss some more points here. Resistance we are discussing now. Wire bent into the form of circle. See here, they can ask you here some more things. Stretching the wire. A wire of resistance R is stretched. Stretched. If you stretch wire, very important concept this is. If you stretch this wire, its length will increase. But at the same time, its area of cross section decreases. Two changes are there. Stretching, two changes are there. Length changing, length increasing, radius decreasing. two changes. But in question, what they do? A wire is stretched so that its length is increased by 20%. A wire is stretched so that its length is increased by 4%. What is the new resistance? Only length change they will give. But radius also changing, no? This problem, some students, what they do, length change, they gave no length change. So R proportional to L, no? Resistance proportional to L, they will use this. Resistance is proportional to L under one condition. That is when the resistivity and area are constants. Then resistance proportional to L. Suppose if I have two separate wires of same area of cross section, two separate wires I have, but one is long wire, other is short, length different, but area same. Material is same. Material also same means resistivity is same. Rho, A. They are same. Length different. In this case, I can write R proportional to L. R1 is to R2 is L1 is to L2 because length, resistivity and area of cross section is same in this case. But the stretching different. Wire, same wire stretched. Length increased, area decreases, area also changing. When area also changing, how can you write R proportional to L, R1 by R2 equal to L1 by L2? That's not correct, no. Area change also you have to consider, no. So how to do this problem? When you stretch wire, one parameter remains constant for that wire, that is volume constant. So resistance rho L by A, if you take, suppose you want resistance length relation when wire stretched, then what you do is, this you multiply with L and divide with L. L by L you write into area into length volume. No? So you'll get rho L square by volume. Now in this stretching process, anyhow rho same, volume same. So resistance is proportional to square of length you have to use. When wire is stretched, R proportional to L square you have to use. Similarly, wire stretched, its radius becoming half. What is the new resistance they are asking? Now radius change they are giving, length change not given. Then what you do? R is rho L by A. Length I had to eliminate because they have not given a length, they have given a radius change, not length change. I have to eliminate length. In place of length, volume I should bring there. So what you do is multiply this with area of cross section and divide with area of cross section. Then this will become rho into length into area of cross section is volume by A square. Rho same, V same in stretching process are inversely proportional to area of cross section square. Area of cross section again pi r square. Now for wire, pi r square, if I write finally what I get? Resistance inversely proportional to R power 4 you will get. So they will ask questions based on this. Resistances, wire bent into loop, circle, it is stretched. What is the new resistance? Suppose they gave resistance length. A wire is stretched so that length increased by 4%, 6%, like that, small percentage change given. In that case, you can write like this now, delta R by R into 100 is 2 times of delta L by L into 100 and you can solve it now. Similarly, for this, R proportional to R power minus 4, delta R by R into 100 is minus 4 into delta small r by r into 100. For small changes only. Suppose if they give length increased by 20%, what is the percentage increase in resistance? 20% change in length they are giving. Now don't apply this. Now what to do? R proportional to L square na, when it is stretched. You write this R2 by R1 is L2 by L1 whole square, you write. You take initial values 100, R1 100 you take, here L1 100 you take, 100, 100 you write initial values when you solve percentage problems. And length increased by 20% given. So what is the new length L2? 100 plus 20. 120 whole square. And when length increases, resistance also increase. No? R1 100 I took now. R200 plus some X you write and find X. This is procedure. When the percentage change is more, when the percentage change is small, use this. Delta R by R into 100 equal to 2 into delta L by L into 100. For stretching process, I'm talking. From this, find X value, find. You will get answer for this. Okay. So I'm going to next problem. Next problem. A wire of 10 meter long has a resistance of 40 ohm. It is connected in series with another resistance box of unknown resistance capital R and a 2-volt cell. The potential gradient. Oh, potential gradient they are giving. See these students, potential gradient. What is potential gradient? Potential difference per unit length it is. Its value given there, 0.1. Units, another point in this current electricity, always current microampere, milliampere, millivolt per centimeter, like that only. Mostly they'll give like this only. Units also, you need to be very careful while doing problems in this chapter. You need to observe that milli, all this, to convert them. This potential gradient given. Now see, this problem is one resistor is there. This is connected to another unknown resistor R in series. And this combination is in series with a cell. 2-volt cell, and that cell doesn't have any internal resistance there. No internal resistance. He is giving potential gradient of this. Its resistance also given 40 ohm this is. And its total length given 10 meter long it is. Its potential gradient given. This value 0.1 milli 10 power minus 3 per centimeter, 10 power minus 2 meter. Simplify this. Simplify this. I think you will get 10 power minus 2 volt per meter. That is potential gradient. I want total potential. See, when two resistors are in series with a cell, that two resistors will share that potential difference V1, V2. Potential divider rule you have to use. Current same, in series current same now. Same current will be there now in both. V equal to IR. I constant here, I same in both. Means V proportional to R for them. Potential difference proportional to resistance. V1 is to V2 is R1 is to R2. V1 by V2 is R1 by R2. We need to use this. When you look at the two resistors in series, so one resistor potential given, immediately should get this idea. Potential divider rule where to apply. So V1, let us find V1, because this first wire potential gradient given now, V by L is 10 power minus 2 volt per meter. Find V, first wire potential difference, this 40 ohm potential difference, you find it. 10 power minus 2 volt per meter into length in meter, you're right, meter. He gave meter only, 10 meter. So you're getting 10 power minus 2 into 10, 0.1 volt. 0.1 volt you are getting. V1. V1.1 you got. V1 plus V2 should be how much? How much this V1 plus V2? Here this battery doesn't have internal resistance. Zero it is. When internal resistance zero, terminal potential difference is equal to EMF only, EMF of battery. So V1 plus V2 total value must be 2 only. Then V2 is 2 minus V1, 2 minus 0.1. That is 1.9 volt. So I'm substituting in this. 0.1 by 1.9 equal to R1 by R2. R1 40 given now. R2 unknown R. From that find R. 1 by 19 is 40 by R. R is, find that R value. 40 into 19. 760. Okay. I'm going to next problem. Next problem. Ohm's law. This problem is Ohm's law. Graph given, no? Potential voltage current graph given is based on Ohm's law. What is Ohm's law equation? V equal to IR. VI graph must be straight line through origin. V by I equal to R. A very easy problem this is. Suppose if this angle is theta, slope of this graph tan theta must be this V by I. V by I, nothing but resistance only. V by I, find that V, 4 volt per that current 4 by 4, 1 ohm. Very easy. 1 ohm. Physics, very easy concept. If you are clear with your concept, physics easy. This is drift velocity concept. A current of 10 ampere is maintained in a conductor of cross section centimeter square given, observe it. And the number density of free electrons is 9 into 10 power 28 meter power minus 3. Here meter, there centimeter. Observe that. Drift velocity. What is this drift velocity formula? I by NEE. In this, what is N? Free electron density means total number of electrons by volume of that conductor. Number of electrons per unit volume. That only given here directly. Finish. Formula based this is current 10 ampere given 10 ampere by 3 electron density 9 into 10 to the power of 28. SI unit only there. Area of cross section 1 centimeter square he gave. This we need to convert into meter square. How much? 10 power minus 2 meter square minus 4 into 1.6 into 10 power minus 19 coulomb electron charge. This will give you answer. So this 9 into 1.6. Okay, this 1.6, 1.6, 16 by 10 you write. 16 by 10, 10 goes up now. So what you will get is, this 10 power all let us keep aside. 9 into 1.6. 9 into 1.6, 14.4. All other 10 power, that all separate it. 6. Answer should start with 6. Because 14 into 6, nearly coming 14.4 into 6, nearly coming to this 1. Na? So answer must start with 6. It should be more than 6. First option, I think. If you simplify this, first option. Elimination methods are to apply and save time. Okay, simplification you have to do. You need practice, not me. This very important problem. I like this problem so much. This very important problem. Unbalanced Wheatstone bridge this is. What is asking here? Is giving one network and is asking potential difference VA minus VB how much? What is this? See this? Battery. P, some Q, some R, some S. A, B, C, D. 4 resistors are connected to form 4 junctions. 4 junctions. See where battery connected? Battery connected between 2 opposite junctions. Either AC or BD. Any one pair of opposite junctions. Between them battery connected. This is Wheatstone bridge. Sometimes they'll deceive you. In this Wheatstone bridge, they'll give 4 resistors like this. 4 they'll give. And between 2 adjacent junctions, they'll show battery like this. P by Q equal to R by S satisfied with this Wheatstone bridge. If you do like that, that is wrong. This is not that. See here, this is different. Wheatstone bridge means 4 resistors connected to form 4 junctions. At between one pair of opposite junctions, battery connected. This is not Wheatstone bridge. And what is this circuit principle? If the ratio of resistances in this series arm P by Q is equal to ratio of resistances in this series arm, other series arm, R by S, is satisfied if the values of these 4 resistances are such that P by Q is equal to R by S, then this point B, this point D are at same potential. B and D are at same potential. The potential difference between these two other pair of opposite junctions will be 0. You connected battery between one pair of opposite junctions, no? If this ratio is satisfied, potential difference between other pair of opposite junctions will be 0. These two are at same potential. Even if you connect here one resistor, in this middle resistor, current doesn't flow. That is Wheatstone bridge principle. Then this bridge circuit is said to be balanced Wheatstone bridge. Look at this. This 4 ohm, 2 ohm, 2 ohm, 4 ohm. P by Q is not equal to R by S. That is unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge means the potential difference between this pair A and B is not 0. They are not at same potential, A and B. There is a potential difference between A and B. Is asking that. Is asking that only. So how to solve this? Very important problem. Practice this. Current from battery, I you take. At this joint, it will split into two now. I1, I2. Find I1, I2. You take this point as P. You find potential difference between P and A. That means Vp minus Va. Find this Vp minus Va. What is potential difference between 2 points? Product of current flowing between those 2 points and resistance between those 2 points. Current flowing is I1 and resistance between P and A is 4. I1 into 4. Find this. Then find potential difference between P and B. P and B. Between these two you find Vp minus Vp. Same. Current flowing from P to B, I2 into resistance is 2 ohm here. But what do you want? Va minus Vb. Means this second equation minus first equation, if you write, you will get answer Va minus Vb. Vp minus Vb minus of Vp minus Va is nothing but Va minus Vb only. Do this. So first I1, I2, we need to find I1, I2. First that I you should find. How to find I? EMF by resistance in the external circuit plus internal resistance. Many times I told you we used this earlier. What is EMF? 10 volt by resistance in the external circuit. This 4 and 2 in series now, same current is there in them. 6, 4 plus 2. 2 plus 4, these two in series, again 6. 6 and 6 are in parallel. 6, these two are in parallel. Then what is the effective resistance of these? 6 into 6 by 6 plus 6. R1, R2 by R1 plus R2. I know you know this very well. 3 you will get now. Plus internal resistance. Print mistake. Internal resistance here coming as 1 ohm. You take it as 2 ohm. 2 ohm you take. 3 plus 2. 2 you take internal resistance. Then 10 by 5, 2 ampere is the total current. Now, here and here, what are the resistance total in this branch? 4 plus 2, 6. In this branch also 6. And what is happening here? 2 ampere current is coming into this branch where there are 2 resistors, equal resistors. When resistances are equal, this current will split as I1, I2 equally, because current inversely proportional to resistance, when potential difference same, I inversely proportional to R, resistance is equal. So current will split equally. So in this 1 ampere, In this also 1 ampere will be there. 1, 1. So now what is this I1? 1 ampere. What is this I2? 1 ampere. Then what is potential difference between P and A? 1 into 4, 4 volt. What is potential difference between P and B? I2 1, 1 into 2, 2 volt. Now VA minus VB equal to VP minus VB, VP minus VB, 2 volt you got. 2 you got. VP minus VA, 4 you got, minus 4. So answer is minus 2. Minus 2. Fourth option. Finish. Going to next. Yes, this is very important. Almost all models till now we covered. Now this is electric power, last model. Important models. It takes 12 minutes to boil 1 liter of water in a electric kettle. Due to some defect, it becomes necessary to remove 20% of the turns of that heating coil in the kettle. After that repair, how much time will it take to boil same amount of water? 1 liter, here also 1 liter only. How much time is asking? Power, electric power, heat produced. What is electric power? V square by R, I square R, VI. These are the relations. Total heat produced, V square T by R, I square RT, VIT. Power is heat produced per unit time. Heat produced per unit time. Now in this question, if you observe, which formula to choose here? V square by R, I square R, which one? That depends on out of V and I. V and I, which is constant you observe in both cases. Then that formula, if you use, easy it is. One coil you are connecting to mains. Then 20% of that coil you are cutting and removing the remaining coil, again connecting to same mains. Means what is same? Voltage. V is same. What is changing here? Resistance changing. That is this problem. So power equal to V square by R. Heat equal to V square T by R. This you have to use now. Now to boil water. What is the amount of heat required to boil water in calorimetry? You will do now ml, where L is latent heat of water, m is mass of water. This heat is supplied by that heating coil, V square T by R. So ml equal to V square T by R. Now, what is asking us to find time, time. Let us make formula for time here from this. Cross multiply mLr by v square. Now, in this problem, same amount of water, na, in both cases, their mass same. Anyhow, latent heat of water is constant, same. And in both cases, that coil is connected to same mains, voltage same. mL by V square is a constant. That means I can write time proportional to resistance. The time taken to boil water in this problem is proportional to resistance. Then T2 by T1 is R2 by R1. T2 by T1, where is T1? 12 minutes. R1 is giving percentage, na? So I'm taking 100. R1. 20% of the turns of coil cut and removed means remaining coil length is 80%. Length 80% means resistance will be 80%. So this will be 4 by 5. So T2 is 12 into 4, 48 by 5, 9 point something you'll get. Yes, this is answer. Now, some points briefly I want to tell you about this power. See, one single coil, when it is used, coil A, when it's of resistance R1. When A is used, time to boil water is T1. They will give this like this. Another model I'm telling. And another coil B is there. Its resistance is R2. When B is used, time to boil water is T2. This they will give. Individually, when A is used, time to boil is T1. When B is T2. When both are used in series, then the time to boil water is dash. Or when both are used in parallel, what is the time taken to boil the same amount of water? Like this, another important is there on power. This how to do is, what is changing here? When one resistance is R1, next to R2. When they are connected in series, R1 plus R2, na, the effective resistance changing, voltage is same. So again, you have to use that only. ML equal to V square into T by R. Here R and T now changing, R and T now changing. What I am doing is R formula I am writing from this. V square T by ML. This V square by ML whole thing is a constant in this process, in all the cases. So I'm writing some K. R is KT, I'm writing. Now, when both the coils are used in series, what is their effective resistance R value? R1 plus R2. Now, in place of R, KT, I'm writing, where T is the time taken to boil water when both are used in series. KT. R1 is KT1, R2 is KT2. K will cancel. T equal to T1 plus T2 you'll get. This is the time taken to boil the same amount of water when both the coils are used in series. Suppose when both the coils are used in parallel, combination to same mains, what is time taken to boil water is asked. Then what you do in parallel combination, effective resistance is 1 by R equal to 1 by R1 plus 1 by R2. RKT, R1 KT1, R2 KT2, K cancel. 1 by T equal to 1 by T1 plus 1 by T2. T equal to T1 T2 by T1 plus T2. This is time taken to boil the water when those two coils are simultaneously used in parallel combination. This is also very important model. Power problems, these are. Different models important, I'm just discussing. And you remember one more point, in any electric circuit, the power dissipated will be maximum when resistance in external circuit and internal resistance of cell are equal. Power dissipated is maximum. Current also maximum, power is maximum when external resistance in the circuit and internal resistance of cell are equal. Suppose they give like this. One 6 ohm resistor and 3 ohm resistor are connected in parallel to a cell. Power in this circuit is maximum. What is internal resistance of the cell? They are asking. The internal resistance of this cell must be equal to the effective external resistance. In the external circuit, 6 and 3 are in parallel. Their effective value, 6, 3 parallel, R1, R2 by R1 plus R2, if you apply, 2 ohm you will get. External resistance. Internal resistance also must be 2. These are important points. Okay, students, I wish you all the best. We'll meet in the next session. All these notes will be sent to you in PDF form. Okay. Students, all these notes will be sent to you in PDF form. Okay.